Guys, welcome back. Today I'm gonna go over February March 2018 from the IGCSE Chemistry exam. Let's get started. Question 1. This question is about gases. Question A. The following substances are gases at room temperature. Identify by letter a gas which combines with water to form an acid rain. So that's sulfur dioxide. It combines with H2O to make sulfuric acid. Two gases which exist as diatomic molecules, that's chlorine, obviously, and carbon monoxide, since it exists as CO2 as well. So carbon monoxide and chlorine. A gas which bleaches damp litmus paper, that's chlorine again. A gas which is used as inert atmosphere in lamps, that's argon. Two gases which are found in clean dry air, so we're looking for carbon dioxide and argon, CO2, AR. Two gases which are found in refinery gas, so the refinery gas is a mixture of different hydrocarbons. So the hydrocarbons we have here are CH4 and C3H8, so CH4 and C3H8. What's a covalent bond? Question B, NF3 has a covalent bond. What is covalent bonds? So covalent bonds are sharing of pairs of electrons. That's the answer that the mark scheme is looking for. Complete the dot and cross diagram to show the electron arrangement in a molecule of NF3. Show outer shell electrons only. So the first thing we can do is to fill the bonds between N and F. So one dot and one cross here, one dot and one cross, and one dot and one cross. And we should count the number of electrons that nitrogen is having around it now. So 1, 2, 3, 4, 5, 6, and it should have 8 electrons in total. So we should add extra 2 here to add up to 8. Now if we count the electrons for fluorine, in each fluorine atom, we have 1, 2, and we have to add 6 more electrons. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Question C. Air is a mixture. Nitrogen and oxygen are the most common gases in air. What's meant by the term mixture? A mixture is two or more substances not chemically combined. Chemically combined. State the percentage of oxygen to the nearest whole number in clean dry air. That's 21%. Describe the steps in the industrial process which enables nitrogen and oxygen to be separated from clean dry air, and use scientific terms in your answers. So the first thing to do is to liquefy or cool down the air. So liquefy air. And the second thing we can do is boiling air, and then we should collect the gases depending on the boiling point. Which physical property of nitrogen and oxygen allows them to be separated? That's the boiling point. Question 2. Sodium chloride is a typical ionic compound. A. The diagram shows part of lattice of sodium chloride. Complete the diagram to show the ions present use plus for Na ions and minus for Cl minus ions. One ion has been completed for you. So since we have a positive over here, we should add to each adjacent ion to the positive charge a negative charge. So here a negative, and there we have another negative. And then we should add to each ion that is adjacent to the negative charge a positive charge. So here is a positive charge, and here is another positive charge, and for this one another positive charge. Now add negative charges to each ions adjacent to the positive charges. So that's a negative charge here and another negative charge here. How many electrons does a chloride ion has? So the chlorine originally has 17 protons and 17 electrons when it's an atom. But in the case of ions, since it got an extra electron from the sodium, it would have 18 electrons. Identify an element which has atoms with the same number of electrons as a sodium ions. So as we mentioned, a sodium gave 1 electron to chlorine to make chloride ion and a sodium ion. So Na was supposed to have 11 electrons. Now it has Na plus has 10 electrons only. And the atom that has 10 electrons as well as sodium ion would be neon. Question B. Electrolysis of concentrated aqueous sodium chloride is an important industrial process. What is meant by the term electrolysis? So electrolysis is breaking down of ionic compounds using electricity. Name the products of electrolysis of concentrated aqueous sodium chloride. So the first product that forms in the anode would be the chlorine gas, chlorine. The second product that is formed in the cathode would be hydrogen, since it's less reactive than sodium in the reactivity series. And the third thing that would form is from the leftovers in the electrolyte. So we had NaCl and H2O originally, and then hydrogen formed at the cathode and chlorine was formed in the anode. So we're left with OH. We dropped 1 hydrogen, and we're left with an O and an H as well as Na. So that's form NaOH, or sodium hydroxide. Write an ionic half equation for the reaction at the cathode and include state symbols. So it was hydrogen plus in aqueous state plus electron forming H2 gas. So as we can see here, we have 2 molecules of hydrogen, and on the other side we only have 1, so we should balance it. So we're gonna add 2 here and 2 in the electrons, and this is how it looks like when it's balanced. Silver chloride can be made by reacting aqueous sodium chloride with aqueous silver nitrate. The other product of the reaction is sodium nitrate. The chemical equation for the reaction is shown. So that's NaCl in the aqueous state with silver nitrate in the aqueous state as well, forming silver chloride that is in the solid state, as well as sodium nitrate in the aqueous state. So a student attempted to make the maximum amount of sodium nitrate crystals. The process involved 3 steps. Step 1, the student added aqueous sodium chloride to aqueous silver nitrate and stirred. Neither reagent was in excess, so he added equal amounts of sodium chloride and silver nitrate. Step 2, the student filtered the mixture. The student then washed the residue and added the washings to the filtrate. The student obtained sodium nitrate crystals from the filtrate. So, question 1, describe what the student observed in step 2, in step 1 I mean. The student added aqueous sodium chloride to aqueous silver nitrate and stirred. So he started seeing silver chloride forming. He observed AgCl solid forming. Why was the residue washed in step 2? So the reason why he washed the residue and added the washings to the filtrate is because some of the sodium nitrate molecules are sticking to the solid of silver chloride. So when he washes it, all the sodium nitrate is dropped back to the solution. So the answer would be to remove any sodium nitrate that was sticking on AgCl or silver chloride. Give the names of 2 processes which occurred in step 3. So in step 3 we had crystallization and filtration. Crystallization and filtration. Filtration. The student started with 20 centimeters of 0.2 mole per decimeter cubed of sodium chloride. Determine the amount of sodium chloride that was used. So the volume over here, and we have the concentration. So we're gonna use this law that says moles is equal to concentration multiplied by volume. But the first thing, multiplied by volume in decimeter cubes. But here we have the volume in centimeters. So the first thing we can do is to convert centimeters to decimeters. So that's 20 divided by 1000, and that makes 0.02 of decimeter cube. And then, since we converted this to decimeters, the only thing we should do next is to multiply the volume by concentration. So that's the volume in decimeters cubed, and that's the concentration over here. This is the concentration. So 0.2 multiplied by 0.02, that gives us 4 multiplied by 10 to the third power, to the negative third power. The yield of sodium nitrate crystals was 90%. Calculate the mass of sodium nitrate crystals made. So in chemistry, it's like impossible to make 100% efficient process. We always lose some stuff in between the processes. So in this case, we lost 10% that was supposed to form of the crystals. So to find the real amount of moles that was formed, we should calculate the theoretical number of moles that was here. That was 4 to the negative third power, 4 multiplied by 10 to the negative third power, multiplied by 90%. That makes 3.6 multiplied by 10 to the negative fourth power. Write a chemical equation for the action of heat of sodium nitrate crystals. So when we heat NaNO3, that makes sodium nitrite, So we had NO2 instead of NO3 plus oxygen gas, and then we should balance it. So here we have 3 oxygens, on the other side we have only 4, so that's 2 and that's 2, that's 4. So we can multiply this by 2 to make 6. 2 multiplied by 4 plus 2 is 6, and we add 2 here, so 2 multiplied by 3 is 6 also. So this is how it looks like when it's balanced. Question 3. Limestone rock is mainly calcium carbonate. The limestone cycle is shown and each step is numbered. Complete the box to give the chemical name and formula of lime. So when we heated calcium carbonate, we will end up with calcium oxide or lime. Question 2. Which step involves a physical change? So here we can see that calcium hydroxide was in solid state, and then when we added excess of the water, it became aqueous. So the step was step 3. What type of reaction is step 1? When we heated calcium carbonate to make calcium oxide, it decomposes in a process called thermal decomposition. Thermal decomposition. Suggest how step 2 can be reversed. So in step 2 we added water, and to remove this water we can simply heat it up. Write a chemical equation for step 4. So in step 4 we had calcium hydroxide, we added carbon dioxide, and this formed calcium carbonate. So let's write this down. So we had calcium hydroxide plus CO2, that made CaCO3, and the OH made water. Explain why step 4 is a neutralization reaction. Refer to the substances reacting in your answer. So we know that calcium hydroxide is basic and carbon dioxide is acidic. So when they react together, that makes a neutralization reaction. So we're gonna say that CO2 is acidic and calcium hydroxide is basic. Question B. Dolomite is a similar rock to limestone. Dolomite contains magnesium carbonate, MgCO3. Write a chemical equation for the reaction between magnesium carbonate and dilute nitric acid. So magnesium carbonate with nitric acid HNO3 makes obviously CO2, H2O, and magnesium nitrate. But the magnesium has 2+ charge while the nitrate has minus charge, so we're gonna add 2 for the nitrate here, and then we're gonna add another 2 here to balance the equation. So this is how it looks like when it's balanced. Question C. Forsterite is another rock which contains a magnesium compound. A sample of forsterite has the following composition by mass: Mg 2.73 grams, Si 1.58 grams, oxygen 3.6 grams. Calculate the empirical formula of forsterite. So the first thing we're gonna do is to calculate the moles of each atom or each ion. So oxygen here, we have 2.73 grams of magnesium divided by the molar mass, which is 24, that gives us 0.11. And for silicon we have 1.58 and the molar mass is 28. That gives us 0.056. For oxygen we have 3.6 grams divided by 16. That makes 0.225. Now to find a ratio between all these three, we should divide by the smallest number, which is in this case is 0.056. So 0.056 divided by itself makes 1, and here 0.11 divided by 0.056 gives us 1.96. And for oxygen, 0.225 divided by 0.056 gives us 4. So we have 2 here, that's rounded to 2, 1 here, and 4 here. So it's Mg2SiO4. Question 4. Ammonia is an important chemical. Ammonia is a base. In chemistry, what's meant by the term base? A base is a proton donor. Write a word equation to show ammonia behaving as a base. So basically we're gonna react ammonia with any acid. So we're gonna say ammonia plus hydrochloric acid gives us ammonium chloride. B. Ammonia reacts with chlorine. The chemical equation is shown. So that's the chemical equation over here. 2NH3 plus Cl2 gives us N2 plus 6HCl. Calculate the volume of chlorine measured at room temperature and pressure needed to react completely with 0.68 grams of ammonia. So we have the mass of ammonia over here, and we can get the molar mass. So the molar mass of nitrogen is 14, and we have 3 hydrogens, so we're gonna add 3, that's 17, and then this is mole per gram. This is the molar mass of ammonia, and we're gonna use this to find the moles of ammonia. So moles of NH3 is equal to the mass 0.68 grams divided by 17 is equal to 0.04 moles. So, and now then we're looking for the moles of chlorine. So we had 2 moles of NH3, and that gives us 0.04 moles of ammonia. And if we have 3 moles of chlorine, how much that would give us? So we're gonna multiply 0.04 by 3 and divide by 2. So 0.04 multiplied by 3 divided by 2 is equal to, that's 0.06. So that's the number of moles of chlorine. Now we want to look for the volume. So the volume is equal to moles multiplied by 24. So 0.06. This is volume in decimeter cubes. So 0.06 multiplied by 24 gives us 1.44 decimeter cubes. But here we want the answer in centimeter cubes, so we're gonna multiply by 1000. 1.44 multiplied by 1000. 1440 centimeters cubed. The chemical equation can be represented as shown. So this is the chemical equation for some reaction. Use the bond energies in the table to determine the energy change delta H for the reaction between ammonia and chlorine. So the first thing we can do is to count the number of different bonds we have, or number of bonds we have basically. So we have 1, 2, 3 of the NH3 bonds. So we're gonna say that we have 3 NH bonds, but we have 2 over here, so 2 multiplied by 3 is 6. And we're gonna add this to 3 Cl molecules. So that's 3 multiplied by Cl, and that gives us the energy needed to break the bonds. So we're gonna plug in the values for NH bond and Cl bond. So that would be 6 multiplied by 390 plus 3 multiplied by 240, and that's equal to 3060 kilojoules. Now we're looking for the energy released when bonds are formed, so we're gonna look at the products. We have one of the N triple bond N, so we have N triple bond N multiplied by 1 plus 6 of the HCl, so plus 6 HCl, and that is equal to 945 multiplied by 1 plus 6 multiplied by 430. So that's equal to 3525. So that's the answer, 3525. And then we're gonna calculate the energy change, which is the difference between this and that. So that's 3060 minus 3525, and that is equal to 465 kilojoules. Now questions 3, is the reaction endothermic or exothermic, and explain your answer. So the reaction is exothermic only if the value of delta H is negative, but in this case the value is positive here, so the reaction is endothermic. So we're gonna say that the reaction is endothermic because delta H is positive. Question C, ammonia reacts with oxygen at high temperatures in presence of a suitable catalyst to form nitric oxide. Explain how this chemical equation shows ammonia acting as a reducing agent. So we can see here that ammonia was just ammonia, and then it became oxidized in this. See here that ammonia was just NH3, and then in the product side it gained oxygen. So when something gains oxygen, it is oxidized and it reduces the other thing. So in this case, because ammonia is oxidized, NH3 was oxidized, so it is acting as a reducing agent. Suggest a suitable catalyst for the reaction from the list of metals. Give a reason for your answer. So we can see here that this is a group 3 element, that's a group 2 element, that's a transition metal, that's group 1, and that's group 1. So we know that the only group that acts as a catalyst is transition metals. So we're gonna say that platinum is the catalyst because it is a transition metal. Transition metal. Question 5. Alcohols are a family of organic molecules which have the same general formula. What is the name given to any family of organic molecules which have the same general formula and similar chemical properties? That's the homologous series. Give the general formula of alcohols. So if we look at some alcohols, we're gonna see that this sequence. So the general formula of something like ethanol is C2H5OH. Something like propanol is C3H7OH. That we can name the number of carbons as N, so it would be Cn, and then we have double the N plus 1. So 2 multiplied by 2 is 4 and plus 1 is 5. Same here. 2 multiplied by 3 multiplied by 2 plus 1 is 7. So we're gonna say that the H is 2N plus 1. And then we have in both of them OHs. So plus 1 and OH. So this is the general formula. Cn H2N plus 1 OH. And obviously we have to memorize it for the exam. Propanol can be made from propene. Name the reagent and give the conditions needed to convert propene into propane 1-ol. So the reagent needed to... Question C. Propanol can be made from propene. Name the reagent and give the conditions needed to convert propene into propane 1-ol. So the reagent needed is steam, and the conditions is a catalyst, basically. Catalyst. Write a chemical equation for the complete combustion of propane 1-ol. So this is how the complete combustion should look like. C3H7OH as what we've written over here, plus O2, and the type of combustion is complete, so plus CO2, the product is CO2 plus H2O. So this equation is not balanced, so we're gonna try to balance it right now. So we have 3 carbons here, we're gonna multiply this by 3. We have 7 plus 1 hydrogens, that's 8. So we're gonna add 4 here. That makes 4 multiplied by 2 is 8. So we have 8 hydrogens here, 8 hydrogens here, 3 carbons here, 3 carbons there. That's perfect for both carbon and hydrogen. Now for oxygen, we have 6 oxygens here and 4 oxygens there. That's 10. Over here we have 2 oxygens and 1 oxygen. That is 3. So if we find the difference between the number of oxygens in the left hand side and the right hand side, we're gonna find that is 7. 10 minus 3 is 7, and that's odd. So it's kind of hard to like balance the equation when the difference between a reactant and a product is odd. So the thing we can do is to multiply the coefficients in the whole equation by 2. So the 1 over here should be 2, the 3 in here should be 6, and the 4 over here should be 8, and then reconsider the whole thing. So we have over here we have 8 oxygens, and here we have 12 oxygens. So 12 plus 8 is 20, and over here we have 2 oxygens and 2 oxygens there. So we have 4 oxygens in the left hand side, 20 oxygens in the right hand side. So we're missing 18 oxygens in the left hand side, and what we can basically do is to add a 9 here. So that's 9 multiplied by 2 is 18, and 2 in this and 2 here is 20. 12, 2 plus and 2 here adds with the 18 makes 20. So this is how the equation is balanced. Question D, a simple sugar can be represented as shown. Simple sugars can be polymerized to make more complex carbohydrates. Complete the diagram to show part of carbohydrate polymer made from the simple sugar shown. So when we polymerize a monomer, we're gonna take an OH from one side and an H from another side to make H2O. So if we take OH from here, so let's copy this over here. So here we have an O connected here, and nothing is connected over here, and then O is connected here, and nothing is here because the OH went over. So on the left hand side of this box we're gonna have an oxygen, and the right hand side we're gonna have it empty. So this is how the polymer looks like the carbohydrate polymer. Name the chemical process which occurs when a carbohydrate polymer is broken down into simple sugar. This process is called hydrolysis. What conditions are needed for this process to occur? We need either enzyme or acid. Chromatography can be used to identify simple sugars in a mixture. A student analyzed the mixture of simple sugars by chromatography. All the simple sugars in the mixture were colorless. What's the name given to the type of substance used to identify the positions of the simple sugar on the chromatogram? So that's the locating agent. The student calculated the RF value of a spot on the chromatogram. Complete the expression for the RF value of the spot. So we always have to know that the RF value should always be less than 1. So to be less than 1, we should have the denominator bigger than the numerator. So the RF formula is the distance moved by the spot divided by the distance traveled by the solvent. So if you kind of get confused with this formula, always remember that the RF value should be less than 1. So if we want to have something less than 1, we should have the numerator bigger than the denominator. Question 3. How could a student identify a simple sugar from its RF value? So to identify a sample, we should compare it. He should compare the found RF value with another known value. Sometimes not all the substances in a mixture can be identified from the chromatogram produced. Explain why this may happen. So this may happen because some substances may have the same RF. So that's everything with this exam. If you like this video, share it with your friends, and don't forget to hit the like button. And have a nice day, guys.